welcome to the Deep Dive. Today, we're jumping into something pretty massive. China's huge push to build its own AI chip ecosystem. It's incredibly ambitious stuff.
It really is. The scale is something else.
And the stakes couldn't be higher, frankly. So our mission today is to unpack this whole national effort. We're working from a really detailed report, Global Technology and Geopolitics Intelligence Unit, dated June 2025.
A very insightful piece.
Yeah, get ready for some critical insights. Might shift how you see things.
Definitely.
Okay, so let's kick things off with the big question. Why AI chips? Why are they so vital for China? Like right now, what's the urgency?
Well, that's exactly the place to start. The urgency, a lot of it comes directly from U.S. export restrictions.
Oh, okay.
Specifically, the bans on those top-tier AI chips. We're talking Nvidia's A100, H100, even the H20.
The ones needed for training the really big AI models.
Precisely. Those chips are essential for training large language models. So those bans have really accelerated China's push for tech sovereignty.
So it's less a nice to have and more a direct response to being cut off.
Exactly. And, stepping back, AI and semiconductors aren't just tech anymore. They're really seen as core to national power, economic strength, even military advantage.
Right.
China has this enormous amount of data, right? Just vast quantities, but without the compute power.
It's bottlenecked.
It's totally bottlenecked. All that data, you can't process it effectively. So yeah, this is all happening within that bigger U.S.-China tech competition. You see it with the export bans, the U.S. Chip Act trying to boost domestic production.
And things like UK's tech sharing, too.
Right, all part of the same picture. It's a strategic battleground.
Okay, so the why is crystal clear. National strategy, dealing with restrictions. That leads us to the who. Who are the main players, the obvious champions China's really betting on here?
Yeah, good question. When you look at the key players, Huawei is probably the biggest name that jumps out.
Okay, Huawei.
Through their Silicon division, their Ascend series chips, they're front and center. Chips like the Ascend 910, 910DB, 910 OC, and there's even a newer 920.
And how good are they? Are they really competing?
Well, the report says they're remarkably comparable to Nvidia's A100. Now, that's in select tasks, not across the board.
Okay, so comparable in certain areas, that's still a big step.
It's a huge step. And crucially, Huawei hasn't just built the chip, they've built the software stack, too. It's called Can-N Compute Architecture for neural networks.
Their answer to CUDA.
Exactly. Think of it as their CUD replacement, trying to build that whole ecosystem. And these chips aren't just prototypes, they're deployed. Pingcheng Cloud Brain, Kunpeng supercomputers, they're in use.
Interesting. So Huawei's a major force. Who else is in this race?
Then you've got Biren Technology. They're focused on general-purpose GPU-like AI accelerators, the BR100, BR104.
Okay.
Their big challenge, though, was the U.S. sanctions cutting off their access to TSMC, the big Taiwanese manufacturer.
Right, that's got to hurt.
It does. So the rumor now, according to the report, is they're trying to adapt, working with Chinese fabs on what they call N+1 and N+2 nodes. Basically trying to make advanced chips domestically, maybe around 7 to 10 nanometers. It's their workaround.
Makes sense. Anyone else significant?
Definitely. Cambricon Technologies. They're known for their MLU series, like the MLU 370. They specialize more in custom AI inference chips. So running the models rather than just training them.
For edge devices and data centers.
Exactly. And they've got big partners, Alibaba, iFlyTek, Lenovo. Then there's Inflame Technology, or Sweezy. Their Sweezy line focuses on cloud AI, both training and inference. They've got backing from Tencent and state capital.
So big tech and government money behind them.
Right. And one more to mention is Hygon Sugon. They're more focused on server CPUs that have AI acceleration built in, and they partner closely with China's supercomputing centers.
Wow. Okay. So it's not just one or two companies. Huawei, Biren, Cambricon, Inflame, Hygon Sugon. It's like they're building a whole domestic lineup.
That's exactly the picture. It really shows the breadth of the effort. They're trying to cover all the key areas.
Which brings me to the government's role. This feels, well, bigger than just standard industrial policy. How is the Chinese government actually orchestrating this? You called it a moonshot almost.
It absolutely feels like a moonshot. And the government strategy is multi-pronged, very aggressive. First, there's the money, huge amounts of it.
Right.
The National IC Fund, people call it the Big Fund, is pouring tens of billions into these AI chip companies.
Tens of billions, wow.
And that's just the national level.
Wow.
Then you have local governments, Shanghai, Shenzhen, Beijing, jumping in with tax breaks, land grants, helping build labs. It's like a fire hose of funding aimed at this problem.
Okay, funding is one piece, but how do they make sure these homegrown chips actually get used, create a market for them?
Yeah, that's crucial. And that's where state-led adoption mandates come in. Government departments, state-owned enterprises, they're essentially being told, prefer domestic AI chips when you buy new systems.
Guaranteed customer base.
Exactly. It helps insulate these new companies. And we're already seeing it. Huawei Ascend, Cambricon chips being used in public security, banking, even real systems.
Okay, so funding, guaranteed market. What else?
Talent. A massive push on talent. They're setting up national semiconductor universities, heavily subsidizing chip design courses at top schools like Tsinghua, Fudan, building that pipeline of engineers.
Makes sense, long-term play.
Definitely. And finally, standards in R&D, pushing for national standards for AI architectures, like trying to establish Canon over CD, setting specs for DPUs,
That's
data
fair.
processing units. They handle networking, storage tasks, freeing up the main AI chips, crucial for efficiency. And they're investing heavily in software too, compiler frameworks like Mindspore, Paddle, adapting open source tools like TVM. It's the whole stack.
It's incredibly comprehensive, but I keep coming back to this one point, the manufacturing. It seems like the Achilles heel.
Yeah.
How capable are China's foundries right now at making these super advanced chips?
You're right to focus on that. The foundry gap is probably the single biggest hurdle. SMIC is China's biggest player here.
Right, Sank.
They can make 7-nanometer chips, that's their N+2 process, and the report says they likely have 5-nanometer working in the lab.
Okay, so they have the tech?
Sort of. The problem is scale and the very cutting edge. Sanctions block their access to EUV machines' extreme ultraviolet lithography.
The ASML machines from the Netherlands.
Exactly. Those are absolutely essential for mass-producing chips at 5-nanometer, 3-nanometer, the real leading edge, efficiently and at volume. Without EUV, it's incredibly difficult, maybe impossible at scale.
Well, so they can design advanced chips, maybe even make some, but mass production at the absolute top end is blocked.
That seems to be the core issue. Then you have Huahong. They're more focused on 28 nanometers and older nodes.
Which are still useful for lots of things, right?
Yeah.
Edge AI.
Oh, absolutely. Good for edge, AI, IoT, automotive, lots of areas, but just not powerful enough for training those massive foundation models. Not competitive there. And others like CSMC and NextChip are growing, adding capacity, but still maybe 3-5 years behind TSMC or Samsung on the most advanced tech.
Yet they're investing heavily. You mentioned a number.
Staggering numbers.
Yeah.
The report estimates over $140 billion being poured into building up domestic fab infrastructure just between 2022 and 2025.
$140 billion.
Yeah. The clear goal is to drastically cut reliance on TSMC and Samsung by 2030. It's a brute force investment approach.
But can money alone solve that EUV problem, or the years of accumulated know-how at TSMC? And in the meantime, while they're trying to close that gap, what are they doing now to keep their AI development moving? Are there workarounds?
That's the key question, right? Money helps, but it can't buy you an EUV machine if it's under export controls. So yes, they've gotten quite clever with short-term workarounds.
Like what?
Well, one major strategy mentioned in the report is basically outsourcing the hardest part, training the big LLMs abroad.
Really? How does that work?
Chinese companies are actually renting server capacity, packed with Nvidia chips in other countries. Places like Malaysia, the UAE, Singapore are mentioned. They do this super compute-intensive training there. Then they bring the trained model, the results, back to China. It bypasses the immediate hardware restrictions for that crucial phase.
It's quite a logistical setup.
Yeah.
Clever, though. What else?
Another tactic is a kind of hybrid approach. Use imported Nvidia chips, maybe the ones still allowed or acquired before tighter bans for the heavy lifting of training.
Okay.
But then use their domestic chips, like the Ascend or Cambricon ones, for the inference stage, actually running the model to get answers. Inference is generally less computationally demanding.
So it stretches their limited supply of top-tier chips.
Exactly. Saves compute power, saves energy. And one other thing the report highlights is how AI firms are adapting their R&D. They're essentially running two tracks.
Two track.
Yeah, like a dual pipeline. One development track assumes access to sanctioned top-tier hardware, maybe for research or export models. The other track focuses purely on optimizing for their domestic chips and compute environments.
Adapting the software, the models, for what they can run reliably at home.
Precisely. It's very pragmatic, whatever works kind of approach to keep making progress.
Okay, so considering all this, the investment, the workarounds, the domestic players, where are they actually seeing wins? What's the tangible progress? And conversely, what hurdles just aren't going away?
Yeah, it's important to look at both sides. On the success side, there are definitely some notable achievements. Huawei's Ascend 910C, for instance.
You mentioned that earlier.
Right. The report claims it reaches up to 85% of the performance of an Nvidia A100, again, in specific benchmarks, likely optimized ones.
Still, 85% is significant. It shows they're getting closer in raw capability for certain tasks.
It's a very significant marker. It suggests that for some key AI workloads, they are developing genuinely competitive domestic alternatives, at least within their ecosystem. That's a faster pace than many predicted.
Are there other real-world examples?
Yes. Alibaba's big language model, Tongyi Qinwen, was reportedly partially trained using these domestic chip clusters. That shows they're not just lab experiments. They can handle large, real-world AI tasks.
Okay.
And despite the export controls aimed at kneecapping their high-performance computing, Chinese supercomputers have climbed back into the top global rankings. That demonstrates growing overall compute power. So progress is definitely being made.
But the bottlenecks remain.
Oh, absolutely. Significant ones. The lack of EUV lithography is still the elephant in the room.
Blocking the path to 3mm, 5mm at scale.
Exactly. That locks them out of the absolute bleeding edge for now. Then there's the software side, the CUDA lock-in.
Nvidia's ecosystem.
It's just massive. Millions of developers know it. Tons of software is built on it. Replicating that kind of mature, robust ecosystem around something like Huawei's Canon is a monumental long-term challenge.
Right, the hardware is only half the battle.
Totally. And often, even with capable domestic hardware, models need significant extra optimization work to run efficiently on it compared to running on Nvidia. It adds friction.
Any other major hurdles?
Well, dependence on foreign IP and EDA tools is still there.
EDA.
Electronic design automation. The software used to actually design complex chips. While China is developing its own EDA tools and IP, they still rely heavily on tools from U.S. companies like Synopsys and Cadence for the most advanced designs. That's another vulnerability.
Okay, so progress on some fronts, but major roadblocks, particularly in manufacturing and software ecosystem, persist. If we zoom out again, connect this to the bigger global picture.
Yeah.
What does this race mean for everyone else?
Well, I think one of the starkest takeaways from the report is this idea of decoupling. We're really seeing the emergence of two distinct AI ecosystems.
One U.S.-led, one China-centric.
Exactly. One built around U.S. tech and its allies using Nvidia, maybe Intel, AMD, and their software stacks. The other increasingly built around Huawei, Cambricon, Biren, and their software like Canon and MindSpore.
Not just chips, but the whole stack.
The whole stack. Design, manufacturing, software standards, how models get trained and deployed. And this split, this bifurcation, it creates risks.
Risks like?
Like different benchmark standards. How do you even compare AI models if they're optimized for totally different hardware and software? How do you ensure interoperability? It could really fragment the global AI landscape.
Leads to a kind of AI nationalism.
Yeah, the report calls it an acceleration of AI nationalism. Both sides doubling down on chip sovereignty, compute independence. It's redrawing the map.
So looking ahead, if you had to gaze into the crystal ball based on this report, what's the prediction for the next, say, 5 to 10 years? Where does China's AI chip capability land by maybe 2030?
The report lays out a potential timeline. For the near term, 2025, 2026, it projects domestic chips hitting maybe 70–80% of that Nvidia A100 performance level more broadly, and expects domestic AI computing clusters to basically double in size.
Okay, continued improvement in scaling.
Then, looking out to 2027, 2028, it suggests the first Chinese chips in the 5-nanometer class could become feasible.
Even without EUV.
Probably not with EUV, but through those workaround fabs, or perhaps by pushing existing DUV deep ultraviolet lithography to its absolute limits. Maybe not as efficient or high yield as EUV, but potentially viable.
Interesting. And longer term, towards 2030.
By 2029, 2030, the report raises the possibility of China reaching parity with Western AI training chips, maybe not on raw specs, but on a cost per FLOPT basis.
So getting similar computing power for the money invested.
Exactly. How much performance bang for their buck? Now, that's a big if. It assumes sanctions don't get significantly tighter and choke off more pathway.
Right. A lot depends on the geopolitical situation.
Oh,
So Wrapping this all up, the core message seems pretty stark. China isn't just playing defense against sanctions. This is a full-court press, a state-driven moonshot aimed at dominating AI compute.
That's a good way to put it.
It's not just about the chips anymore, is it? It's about owning the fundamental infrastructure of intelligence itself.
Precisely. And the report makes it clear, with the sheer scale of funding, the aggressive industrial policy, that growing domestic ecosystem, China's AI chip sector is on track to be a really formidable force by the end of this decade. It's a long game, and they're absolutely all in.
Which leaves us, and you listening, with a pretty big thought. As these two distinct AI worlds take shape, the US-allied one and the China-centric one, what new challenges, what new opportunities does that create for technology, for business, for maybe even our daily lives? How do you plan to navigate this increasingly bifurcated digital future? Something to definitely mull over.